Hello everyone, my name is Thiago, and in this presentation I represent our team from São Paulo State University. We are from Brazil, state of São Paulo. I will briefly present our research entitled Machine Learning for Web Intrusion Detection, a comparative analysis of feature selection methods MR, and PFI. This is a summary of my presentation. I will follow the traditional sequence. In our paper, we compared two feature selection methods with a focus on detecting web attacks in computer networks. Attacks and incidents in information security have been growing in recent years. The figure 1 illustrates a compilation for the number of incidents that occur year by year in Brazil, and that reflects in a certain way what happens worldwide. On the figure 1, the horizontal axis are the absolute number of incidents, and on the vertical axis are the years. In 2019, there were just over 875,000 attacks in Brazil, and in the interval between January and July this year, more than 300,000 attacks have been reported. It's important to note that these figures reflect the attacks that are reported to the agents that compiles the statistics. So they actually reflect a probably very small portion of the reality. Over the years, the use of network package filters, where the filtering rules are established by the sysadmins, was enough to keep the network safe. However, with the evolution of the networks, that is, the packets have more complex anatomy and the attacks are more robust today, it was necessary to bring intelligence to the process of detecting attacks. I mean that using firewalls with static rules is still valid, but is not as efficient as automating a detection process through the recognition of pattern of attacks. In the last few years, the area of network security has benefited from the application of intelligent methods, in particular machine learning methods that basically learn malicious patterns in network traffic, and with that they can classify future data. About the correlated works. The application of PFI to detect web attacks is unusual. Moreover, several works that were cited in our paper used the same dataset to detect this type of attacks. A constant problem in intrusion detection has been to adapt the training time and classification time with the speed at which new attacks reach the network. For this reason, it's very important to select the most suitable features in a training dataset, as the appropriate choice allows that process time is reduced and mainly that performance in terms of detection rate is increased. A previous research by Smith et al., reference 22 in your paper, number 8 in slide, implemented a method for selection feature scaled MR and presented good results in the HTTP CSIC 20 dataset. An interesting point in their research was the use of Microsoft Azure Machine Learning Studio, a tool that's not very popular in the scientific world, but that do with robustness, especially in the college where I teach, Technology College in the city of Ourinhos, in state of São Paulo. We have a partnership with Microsoft here that allow you to use the tool at the machine learning level to our students, and that was a factor that motivates you to implement another method of selecting features of their platform and compare the results with the previous work from the Smita team. With has a paper published in 2019 at the Congress in Singapore. In a simple way, the PFI method makes small changes in the values of the features and verifies how much this impacts on the label assignment. That is, if the feature is of little relevance, the change will not imply change in the classification. But the feature is important, changes will influence the classification. In particular, the PFI function of Azure Machine Learning Studio uses the randomization technique used in random forests to work as a model-independent research classifier. Our methodology consisted of the traditional pipeline of a classification process, seeking to make the process similar as possible to what was done in the work we compared Smita. Therefore, we perform data discretization to ensure that we have adequate values to work with mathematical methods, that is, numerical values, and normalize them to guarantee the same data range for all features, so that no feature has more influence than on another. We use the method of split the data in portions 70-30, with 70% of the data used for training and 30 for testing. The hyperparameters of the models are tuning, a process of optimize the results. Our experiments show significant performance improvements, as can be seen. You can see the colors are the orange bars. Who cannot see the colors are the top bar of each of methods. In short, it can be seen that our case using PFI is more appropriate than MER in this specific context, except in logistic regression, where in terms of accuracy the results were the same, but in the semi-classifier the values, for example, of precision and recall are better with PFI. I thank you for your attention, and I hope I managed to present our paper in these few minutes. This is our main reference. We are at your disposal in doubts. Thank you very much.